I welcome you all to this class, which treating indices, and it's a topic in Maths 101. So, for this class, we're taking indicial equations. Indicial equations. Now, all the questions on the board are actually what? Indicial equations. They are indicial equations. That means equations involving what? Indices. Okay. Now, the way you solve this is a bit different from what we've been doing from our previous classes. It's a bit different. It's just you just have to, how would I put it, make sure or try as much as possible to make sure the left hand side and the right hand side of the initial equation have the same base. With that it becomes easier to solve. Okay, all right, now let's try this. This is a very simple one. We have 1 over 2 raised to power x equals 8. Let's try to solve this. Now, to do this is simple. How? We know that 1 over 2 can still be written as 2 raised to power minus 1 x equals to 8. From our negative index law, this is this, right? 2 raised to power minus 1 is 1 over 2, okay? And that's from our negative index law. Now, from our power law, we can actually multiply the powers here. That's minus 1 multiplied by x. So here we have 2 raised to minus x equals to 8. Now minus 1 times x is minus x, right? Now if you look at the right hand side of this equation, we have 8. Okay? Like I said initially, the trick here is to try to make sure the base on the left hand side and right hand side are equal, or the powers on the left hand side and right hand side are also what? Equal. Now, from here, we know that 8 can be simplified, or we can actually write this as a base 2 number, right? And what's 8 as a base 2 number? That should be 2 raised to power what? 3, right? So we're going to just simplify this as a base 2 number. This is now going to be 2 raised to power minus x equals to 2 raised to power 3. You see that? Now, it's obvious here now that 2 raised to power 3 is 8, but we just try to make it 2 raised to power 3 just to make sure the base on the left hand side equals the base on the right hand side. Now from here, it's just a normal solution and it's almost there, it's almost done, because when the bases are equal, the powers are equal. In mathematics, we just cancel that out, but the reason is simple. When the bases are equal, the powers are equal. When the powers are equal, the bases are also what? Equal. Alright, so what do we do here? We just say negative x equals to 3, and that is happening because the bases are equal. So we just what? Equate the powers. So how do we move the negative sign here? There are two ways to do that. How do that? You then multiply both sides by what? Minus 1, or divide both sides by minus 1. That's just something like that. Divide both sides by minus 1, multiply both by minus 1. The negative attached to x, we just move on to the other side. Okay, so let me just put it down. Multiply both sides by negative 1, right? Negative 1, right? Okay, that's now, let's say, let me just continue here. That's minus 1 times minus x, that's negative 1 times negative x equals to negative 1 times what? 3. So, minus and minus, that's plus. And here gives you what? Minus 3. Minus 1 times 3 is actually minus 3. So here the final answer is what? X is what? Minus 3. Okay? Alright, I'm going to solve this. And we can solve that two ways. I'm just going to do it. So you see it's applying the laws of indices actually. We're solving these questions or all these initial equations applying the laws of indices. Okay? Alright, let me just rub this off and let's do this. Okay. Alright, okay, let's solve this. The first way of doing this, from the left hand side, we can see that the left hand side is trying to tell us that 3 is multiplying 3 square x, is it not? So now we can actually simplify this as 3 times 3 raised to power x equals to 287, right? Yeah, we can do that. Okay, now following the multiplication law, right, of indices, number 1 law actually. Okay, if we look here, 3 what power of 3 is this? That's 3 raised to power 1 because 3 raised to power 1 is 3. So we just, it's not there, but we'll take it that, okay, it's 3 raised to power 1 because 3 raised to power 1 is still 3. Okay, so if this is 3 raised to power 1, the bases are the same, they are multiplying. So what do? We just pick one and do what? Add the powers according to the rule, the law. Okay? Alright, and this is equals to what? 27. We have to repeat what we did in the previous solution, where we say we have to make sure the right hand side is also in base what? 3. And as with what we have here, we know that 27 can also be written as a base of 3, right? Okay, so we're going to do this 3 raised to power 1 plus x, and 27 is 3 raised to power what? 3 raised to power 3. You see, at this junction we have both left hand side and right hand side as what? A base of 3 raised to power. So the bases are equal. What do? We equate the powers. Since the bases are equal, we do what? Just equate the powers. Okay? Alright, so that 1 plus x equals to 3. 1 goes there, collect like terms, right? Should I add? I don't have to write that, okay? Let's say we're collecting like terms or using the balancing method, which way you prefer. X becomes 3. 3 what? 3 minus 1, right? Okay, so x is now what? 2. Very simple, right? Very simple. Alright, that's the first method to do it. That's the first method. Okay, let me just solve it the other way here, which is also possible to do it that way and you stay actually correct. You stay actually correct. Okay, now you can do it this way here. Just look at this. This is multiplying this, and this is 27. So actually, we can remove this 3 here. How do we do that? Divide both sides by this 3. Right? Okay, let's say here is over 3 and here is over 3. Right? This goes and this here is 9. Right? So we have 3 raised to power x equals to 9. Is it not? Okay, now we still have to come back to what we did here. We have to leave 9 in a base 3 number, right? Okay, so this now becomes 3 raised to power x equals to what? 3 raised to power 2. Now you see the bases are equal, so we can now equate the powers. X equals to 2. We're still there, right? Okay, see, any of these methods are actually correct, okay? Just in initial equations, while solving it, just try and make sure the bases are equal or the powers are what? Equal. Alright, let's solve some of these questions and we'll leave some for you to try. At least once you solve them, you get them, no, you're good with indices, you're good with this, at least for initial equations. These are simple initial equations. Alright, okay, let's do the first one there. We have 0.25 raised to power x plus 1 equals to 16. It looks a little bit bulky, right? Or complicated, right? But it's not actually. All you need to do is convert this to fraction. Convert the 0.25 to fraction. How do we do that? I think I said that in a previous class. Just do this. The points represent 1. Every number after the points represents what? Zeros. So this becomes 25 over 100. All raised to power what? X plus 1 equals to what? 16. Okay? At this junction, you see, we can reduce this fraction with 5, I think so, right? Or 25 can actually reduce it, right? Yeah, 25 can reduce it. Can reduce it with 5 because that's 4, right? Okay, we can just say here is 1, here is 4, right? Okay, so we have 1 over 4 x plus 1, that's the power, or that's the index, equals to what? 16. Now we are here, right? Okay, now 1 over 4, we can leave it in negative index form, right? Negative power form, negative index form. Okay, this can be 4 raised to power minus 1 x plus 1 equals to what? 16. Is it not? Right? Okay, now normally what we do, our power law, you multiply this by this. The powers multiply each other in our power law. Okay, so just note that this is minus 1 multiplied by x plus 1. And when you have two tens multiplying the power, please, not to make mistakes. Some of you will just expand this and call it minus x plus 1. You just failed it. You just actually gotten it wrong. Okay, so what you do, let's just do it carefully here. As far as for minus 1 x plus 1 equals to what? 16. Right? Minus 1 is multiplying everything there, is it not? Okay, so we have to expand this, not just multiply by x and just go away. No, you expand it. So minus 1 times x, that gives you what? Minus x, right? Minus times plus, that's minus 1 times 1 is 1, equals to what? 16. You see that? Now, we're back to where we actually can move forward if we don't make 16 to be in the base 4 number, right? And we know that 16 can be a base 4 number, like that's 4 raised for what? 2. Okay, that now becomes 4 raised for minus x minus 1 equals to what? 4 raised power 2. You see, at this junction, it's obvious now that the bases are equal. So what do? We equate the powers. That's minus x minus 1 equals to 2. Balancing method or collecting like terms, minus x equals to 2 plus 1, right? Right? Minus 1 comes here, this minus 1 comes over here. The sign must change, right? Okay. Now, what do? We have minus x equals to 3. Multiply both sides by minus 1, multiply both sides by minus 1, we get x equals to what? Minus 3. Okay? So that's simple, right? Very simple. Very simple. Okay. Let's see. Okay. I'm gonna solve this. Let me solve B. Let's solve B too. Let's solve B. Okay, let me just move this so you can see the question there properly. Alright, let's solve B. Let's solve B part. Let's solve B part. Let me just wipe this off. Okay. Alright. Let's solve the B part. Okay. We have 8 raised by x divided by 4 equals to 16 raised by x divided by what? 2 raised by 2x minus 1. Now, you just have to solve these left hand side and the right hand side separately, leaving them in the same base. Okay? So now, here is 2. We have base 2 here. That's 2 raised to power 2x minus 1. Here is 4, here is 8, here is 16. And if you look at all the numbers we have in this question, they all can be left in a base 2 number. That means we can have 2 raised to power 3 here, we can have 2 raised to power 2 here, we can have 2 raised to power 4 here. Is it not? Okay, so let's just simplify everything so that all of them will be in what? Base 2. Okay, so this 2 raised to power 3, that's 8, multiplied by what? X. This for this, right? Then this 2 raised to power 2, right? Equals to 2 raised to power 4 multiplied by x. And here we have 2 raised to power 2x minus 1, right? Yeah, we're here already. Okay, now what happens here? 3 multiply x to give what? 3x, is it not? This is 2. That means on the left hand side, we should have 2, since they are dividing, we should have 2 raised to power 3x minus 2 equals to, and on the right hand side, since they are dividing and the bases are equal, we should have 2 raised to power 4x minus 2x minus 1. Okay, I told you when you have two terms, please just put it in bracket to avoid making mistakes. Because if you did not put this in brackets, there is every tendency that you might just fail the question, and from this point actually. All right, let's continue. Now over here you can see now that we've written these as this, and both are in the same base. So what's the next thing to do? The bases are equal again. So what do? We equate the powers. We equate the powers. All right, equating the powers, we have 3x minus 2 equals 4x minus 2x minus 1, right? Okay, so let's just solve this. We're done with this. Let's solve this, simplify it further. We have 3x minus 2 equals 4x. This minus has to multiply everything in the bracket. Minus times 2x, that's minus 2x. Minus times minus is plus, and that's 1, right? Okay. All right, so let's just clear like terms here. Okay, we can simplify the right hand side. So this becomes 3x minus 2 equals 4x minus 2x, the like terms here. So this is what? 2x plus 1, right? Okay, now we can just clear like terms, right? 2x comes here, let's minus to move over there. So if 2x comes here, it turns to minus 3x minus 2x equals to the one here. Please put it down first. Minus 2 comes over, turns to plus, right? You see that? Whatever is there, you just have to write it down first. Very, very important. Okay, 2x minus 2x is what? X. 3x minus 2x, they're like terms. You just write your x, they're like terms, right? 3 minus 2 is 1. You just have to put 1 there, but you can't put 1 there now. 1x or x is still the same thing, right? So 1 plus 2, that's what? 3. Good, right? Very simple, easily. Just from here, convert to base 2. Everybody just leave everything here in what? Base 2, we are here. And from here, what do? They are dividing here. Multiply these powers, you get 3x. Since they are dividing, subtract the powers. That's why we have 2 raised to 3x minus 2. The same thing happened here. Here, you multiply this from the power law, right? 4 times x is 4x, so that's 2 raised to 4x. But since they're dividing, you subtract the powers, minus 2x minus 1. The bracket is here because we have two terms, okay? If you have two terms, please always repeat what? Brackets to avoid mistakes, nothing more. All right, okay, that's that. And over here, what did you just equate the powers and simplify? We're down here. This is just a linear equation, so solving it to get x as what? 3. Okay, do I have to solve anyone? Let's see. I've solved this. Okay, let's see. Maybe you try C, D, E, and F. Try C, try D, try E, and try F. 4 questions. Okay, that's good. Practice with it. Leave your answer in the comment section. I will see it and probably react to it. Okay, you can follow us on TikTok, subscribe to our YouTube channel, follow our Facebook page to see more of questions involving what? Math 101. I'm actually here for you guys. Just follow up, you get to know everything. I know when school starts now, most universities or most colleges will just, exam and all what's not. So just follow us up so that you get conversant what we'll be saying. And that'll be that. Alright, thank you. Don't forget to like, subscribe to this channel, Engineer Dan Online Math Class. See you next class.